Ram join பண்ணிட்டாரு.
Right. I think our connected. Okay. Fine. So we'll start with the session, right? So நம்மளோட goal for this session will be on a couple of things. So நான் போன கிளாஸ்ல highlight பண்ணிருந்தேன். We're going to first start with some foundation topics of security. Then we'll get into the product. So நம்மளோட goal in the session will be on two things. One would be about NAT, and then other one will be about firewall and types, right? So first, to go with NAT, and I mean, I always start with the easiest module because everyone would have learned it, would have implemented it in the real time. In a CCNA, everybody would have learned that. This is more of a two-way discussion when we do NAT. So any subject, we start we always go with the purpose, right? First, we always start with the reason why we do that subject. Then, on the subject involve technical terms. Then, how do we configure? How do we configure? Or maybe also the subject we have types. But NAT, general types of NAT, the discussion, right? So first, I just wanted anybody to give your thoughts. For a production network, why or when do we do address translation?
By reducing
Anyone
public
can go
IP.
with your answers. Yes.
Going public, or to connect with public network, internet.
Okay. Users sitting in the office if they want to connect to internet. Okay. Adukku NAT ku enna solla? What is the relationship?
Security, where we will be not, our IP will not be seen by the public.
Okay, fine. That is one of the aspect of NAT. NAT could be seen as a security feature because we are trying to hide our identity, not exposing. Okay. நீங்க பப்ளிக் இன்டர்நெட் போறதுக்கு NAT கம்பல்சரியா தேவைன்னு சொன்னீங்க. Any other reason apart from security feature? Let's say like I'm not worried about the security aspect. Do I still need a NAT when my LAN users wanted to connect to internet?
I don't think so, but it will. Example, we are using modem where internet, we are connecting via internet.
Okay.
So it is, if you're leave security, I don't think it is necessary.
Okay. Others, apart from giving security, yeah.
The private type வந்து பப்ளிக்ல ரூட்டிங் ஆயிருக்கா சார், அதனால வந்து நம்ம
right. So நம்ம internal networkல we more often use private IP addresses which is non-routable over internet, right?
Yes,
so private IPs are நம்ம internal networkல use பண்ணனும் because we have limitation or shortage of IPs, right?
Yes.
We have scope of private IP addresses is helping us to preserve public IPs in fact, right? So நமக்கு ஒரு bulk of private IPs இருக்கு. Any organization could pick one of the range and they can use it for internal network. அதோட purpose வந்து public IP space preserve பண்றதுக்கு, right? So just for since you people said about private IP, just for idea, what are the range of IPs we have in private address? Just to recap, what are the address range we have in private?
We have multiple classes, class A, B, C.
Okay.
10 series, 172 series, 10.0 to 10.255.
10.0 learn 10.255. Okay.
116 to 170 to 31.
120 to 31. Perfect. Right. Then
80 to 168.
Right. 190 to 168. So this range of IP is what we call it as private IP, right?
Private.
In the IP or a specialty, anybody could use this IP. They don't have to purchase or inform anyone, right? Apart from that, Windows, Microsoft systems, they automatically pick an IP called API IP, right? Automatic private IP address. Now, when DHCP is not working properly, Windows machine takes IP automatically from this range. So, okay, leaving that aside, in the range of IP is what most of the organization, either it's a home user or home user connected to a modem and then internet, or it's a small office where we have 3-4 employees only maximum with a printer or something, right? Or it's a medium business scale or enterprise where there are many subnets inside my office. Internal infrastructure, we could use one of the IP from this range. We don't have to inform anyone. But problem, like somebody said in the address limitations, is like it is non-routable over public WAN. Right? Over public WAN, I cannot use this IP for communication. Right? That is one of the reason of a LAN user 10.1.1. He is trying to send an IP packet to internet. In the IP address, I cannot forward my packet to internet provider. Provider will block it because this IP address is non-routable. And IP many people would have used internally, right? They cannot go with the same IP to internet and come back. So that is one instance where our LAN user, when they try to send a packet to internet, our gateway device packet cross this IP address would be changed to one of the purchased public IP from the provider, and then we forward it, right? So for reply traffic, when response traffic comes back from the internet, so reply traffic, the reply packets will be coming back to my public IP. My router have to put it back to my original private IP and then send it to my LAN. So for private to public IP, public IP back to private IP. It could be anything. So private IP to public IP or public IP back to private IP. We perform address translation. One of the scenario where we do it. Second, as like someone said, the security feature on Part-3, it is used to hide our identity. This internet is mandatory, right? So in IP address, I'm trying to hide it, so I'm not exposing my identity to external world. The internet even inside my office, I've got LAN 2. I don't want users. So I don't want users in LAN 2 not to have an idea about my address information of my server. Let's say a server or IP is so and so. I don't want my own organization users not to have an idea about the address of my server. So for a router which is connecting my LAN 1 and LAN 2, I can change this IP as some other IP. Let's say 10.1.6.5. So from this moment, any users in LAN 2, point of view, server or IP, they will think this is the server IP, but originally server IP is something else, right? So if you look at one of the aspects, private IP has been changed to another private IP, right? Because there is a perception always, people have an intention like NAT IP may private to public, people think about it. But remember, NAT is not always about private to public, public to private. It can be one IP to another IP. And the private IP to private IP, private IP to public IP, right? It could be one IP to another IP. It need not be always private address to public address, right? In the scenario, private IP in or private IP can change, right? Fine. So security reasons we could do it. Private app routable public API change, then we send it to internet. Any other reasons? Any other scenario where address translation helps us for communication?
Sir, nama group of IPs are single IP.
Okay, other types of NAT. So that comes under types of NAT. நான் கேட்கறது எங்க NAT தேவைப்படுதுங்கிறது. இதை தாண்டி வேற எங்க நமக்கு NAT comes as a solution for us?
ஐபி சர்க்கிள் டனல் பில்ட் பண்ணும்போது நம்ம NAT ட்ராவர்சல் யூஸ் பண்ணுவோம்ல?
NAT ட்ராவர்சலுக்கும் NATக்கு சம்பந்தம் இல்ல. ஓகே. தென்
அவுட்சைட் பப்ளிக் நெட்வொர்க்ல சார் நம்ம பிரைவேட் இருக்கிற சர்வர் அக்சஸ் பண்றதுக்கு நம்ம NAT யூஸ் பண்ணலாம்.
அது எல்லாமே இங்கே கவர் ஆயிடுது. பிரைவேட் ஐபியை ஒரு ஐபியை சேஞ்ச் பண்ணிரும். இங்க இருந்து வெளியே போனாலும் சரி, வெளியே இருக்கிறவங்க நம்மள அக்சஸ் பண்ணணும். வைஸ் வர்சா இட் இஸ் ட்ரூ, ரைட்? Okay, now assume like என்னோட சைட்டுக்கு என்னோட branch office ஒரு private line we might have taken, right? It may not be internet. Private line அப்படிங்கிறப்ப it could be MPLS or some private circuit is created, right? இங்க நமக்கு ஃபர்ஸ்ட் NAT தேவைப்படுங்களா? கொஸ்டின் நான் ஆப்போசிட்டா கேட்கிறேன். லைக் என்னோட லேண்ட்ல இருக்கிற யூசர் என்னோட பிரான்ச் ஆஃபீஸ்க்கு VPN பத்தி நான் கொண்டு வரல. லைக் சே பிரைவேட் WAN டெக்னாலஜி யூஸ் பண்றோம். Do I need a public IP to communicate to reach out to my remote site? No, right? ஏன்னா நம்மளோட ஐபி பாக்கெட்டை நம்ம ஒரு டெடிகேட்டட் ஒரு விர்ச்சுவல் சர்க்கியூட் வழியா டிராவல் ஆகும்போது பிரைவேட் ஐபியை நான் பப்ளிக் ஐபியை மாத்தணுங்கிறது நெசசிட்டி இங்க கிடையாது. அப்ப இந்த சினாரியோ NAT தேவையில்லை. ஆனா இங்க வேற மாதிரி ப்ராப்ளம் ஒரிஜினேட் ஆகலாம், ரைட்? பப்ளிக் ஐபியோட டிமாண்ட் நமக்கு இல்லை. ஆனா கன்சிடர் திஸ் இஸ் மை கம்பெனி ABC, this is my client, which means it is not my branch office, it's a client side. So if a user in my LAN wanted to communicate, reach out to my client user, client side அவங்க internal network what IP address they would have used, அவங்களோட IP planningல private IP யூஸ் பண்ணிருப்பாங்க. There are chances where they also would have used what IP, a similar IP range they would have used, right? இத நம்ம overlapping IPs ன்னு சொல்றோம், right? When we have two sites having similar IP, they wanted to communicate. என்னோட IP in 10.1.1, என்னோட target system ஓட IP in 10.1. How do I expect them to communicate? I cannot ask the client to go and change their IP scheme. Either I cannot go and change my IP scheme, but I still wanted them to communicate to one another. So our easiest solution, நமக்கு NAT will come in into the picture there. நம்மளோட சைட்ல நம்ம கேட்வே டிவைஸ்ல நம்ம LAN IP I'm changing it to some other address, right? 10.1.5.0 or network change. Remote gateway அவங்களோட LANல their IP address is changed to 172.16.1.0. Now what would happen? என்னோட LANல இருக்கிற users ஓட point of view, my remote LAN is seen as 172, right? For users in this client site, அவங்களோட point of view, நம்ம LAN IP will be seen as 10.1.5. But till the end, they never know they have same IP used between them, right? By translating the addresses, we are making sure overlapping address is not visible to them, right? And at the same time, they can communicate. So when we have two overlapping IP networks needs to communicate, we again go for a NAT. இது ஒரு ஜெனரலா ஒரு கேட்வே டிவைஸ்ல நம்ம எப்ப NAT பண்றோங்கிறது. இப்போ இதே லோட் பேலன்சர் FI மாதிரி டிவைஸ் போனா அங்க வேற ஒரு couple of scenarios இருக்கு NAT பண்றது. நம்ம we are sticking to gateway firewall. Or gateway device would be a router or a firewall. Why? We might do an address translation, right? On what basis we do it? இந்த எல்லா கேஸ்லயுமே either private or public change பண்றது, security reasonsக்காக ஹைட் பண்றது, IP overlapping visibility இல்லாம ஸ்டாப் பண்றதுக்கு when we do a NAT, நம்ம ரவுட்டர்ல டிரான்ஸ்லேட் பண்ணும்போது நம்ம ஆக்சுவல் IP எந்த IP அட்ரஸ் நம்ம ஹைட் பண்றோமோ அந்த IP அட்ரஸ் we call it as what? We call it as local address, right? The original IP or the real IP is called as local address. The translated IP is otherwise we call it as what? Global IP, right? Mapped, NATed, translated, whatever names we use it, right? So in the scenario, in the gateway point of view, this is my original IP, local IP. This is my global IP, right? So our box generally maintains a statistics about which local addresses has been mapped to which global addresses. And the NAT table no சொல்லி பார்த்திருப்போம் see routersல. In firewall language we call it as slate, which maintains the stats about the local IP and global IP, right? It maintains a record about the original IP and the translated IP, right? Some of the technical terms that we use in NAT is local and global address. Mapping of local and global IP information is kept as a record in XLate, right? Now coming to the actual course of discussion, it's about, okay, இப்போ நமக்கு ஒரு basic idea by this time you would have got it, why we need to do NAT. Now the question is how we are going to do that. how one IP would be translated to another IP. On what basis we can do the translation. So we have two classifications there. One is dynamic and the other one is static, right? So dynamically, we have a couple of options like dynamic NAT, right? We have dynamic PAT, right? In case of static, we have static NAT, we have static PAT. Static PAT is something we are going to discuss when we get into the product wise. நம்ம இப்ப recollect பண்றது பேசிக்ஸ்ல நம்ம ஆல்ரெடி perform பண்ண NAT. Those three types of NAT. So நம்ம இந்த types of NAT குள்ள enter ஆகிறதுக்கு முன்னாடி again a general question. I mean nothing about networking. Forget networking. Let's skip this NAT. Let's forget networking. What do you mean by dynamic and what do we mean by static? And I say
Static is
what do we mean?
confident. Static is confident. Dynamic means like variable. It's varying.
Confident illa constant?
Constant, like
constant
stable
or something that doesn't change.
Yeah, doesn't change.
So static அப்படிங்கிறது something that remains same throughout the day, doesn't change over the period of time, fixed, right?
Yes.
Dynamic அப்படிங்கிறது change, okay, changes அப்படிங்கிறதோட reason பாத்தீங்கன்னா it's a decision that is taken at runtime. And the moment we decide on something, which means in the decision எடுக்கிறோங்கிறது it's not pre-decided, something that is taken at that moment, which means the decision may not be same always. Next time when I decide on something, I might change my ideas, right? So dynamic அப்படிங்கிறது something that is chosen at runtime. Live, on that live, we pick a decision on what to do. Static already நம்ம pre-decide பண்ணிட்டோம். This is how this is going to happen அப்படிங்கிறது, right? So when I say NAT, static translation, அப்ப எந்த IP address நம்ம எந்த அட்ரஸ்க்கு சேஞ்ச் பண்ண போறோம்ங்கிறது already it is fixed, pre-decided. Dynamically it is not pre-decided. ஒரு IP எந்த அட்ரஸ்க்கு நம்ம சேஞ்ச் பண்ண போறோம்ங்கிறது not decided upfront on the gateway device. அப்ப ஒரு gateway device, router இல்ல firewall, ஒரு IP எந்த IPக்கு சேஞ்ச் பண்ண போறோம்ங்கிற அந்த டிசிஷனை எப்ப எடுக்க போகுது in dynamic. That is where the important point that we have to remember. When I ask my gateway router to translate my internal IPs dynamically, initially it might have not done any translations. So upon LAN la irukakudi IP is where it is going to translate it. On live, when it receives an IP packet from my LAN. Live la or IP packet in your internal network la irundhu when live packet reaches here, that packet would trigger the gateway device to change that IP to one of the available IP and then send. Appa point to remember there, in the local devices la irundhu IP packet varada mudikum and the address even translate பண்ணிருக்க மாட்டோம், right? That is a point I need to people to remember it. Live la or IP packet local devices la irundhu varada mudikum அவங்களோட அட்ரஸஸ் நம்ம கேட்வே ரவுட்டர் would have not translated it. Okay, இதனால என்ன பிரச்சனை? Now think we have a server inside the LAN, or web server or ஒரு email server, public server னு எடுத்துக்கலாம். So LAN ல இருக்கிறவங்க access பண்ணா இன்டர்நெட்ல இருக்கிறவங்க they can access it, right? Assume like people from LAN, people from internet, they can access it, right? So assume that this is 10.1.100. If I want people from internet to access that server in the private IP, they cannot reach from the internet, but definitely people can public IP there. If I perform dynamic type translation here, adala rendu idhula enna NAT venal neenga example eduthikalam. So nama inga dynamic type translation entire subnet ku perform pannirukonu eduthu, right? அப்ப இந்த IP addressல இருந்து ஒரு IP packet வெளிய போகாத முடிக்கும். சர்வரோட IP இங்க NAT ஆகாது, ரைட்? சர்வரோட IP NAT ஆகலங்கிறப்ப அப்ப இன்டர்நெட்ல இருக்கிற ஒரு யூசர் how does he know which public IP I need to send a packet in order to reach my internal server, right? And in the client server communication, it is the client who starts the conversation. If a client has to start the communication, first packet of the conversation to be started from the remote side. So அப்ப remote side இருக்கிற ஒரு user எந்த public IP க்கு they has to send a packet in order to end up reaching my server, right? That's a big question. ஏன்னா சர்வரோட ஐபில இருந்து பேக்கெட் இனிஷியேட் பண்ணாத முடிக்கும், அவனோட ஐபி இங்க டிரான்ஸ்லேட்டா இருக்காது. அப்போ how remote side user can initiate the connection? The point is, when I do dynamic type translation for my local addresses, my LAN IPs, if you have server type devices, for them this NAT may not work out properly. And our servers generally do not start a conversation with the client. So servers sitting in the internal LAN, if they do not initiate any IP packet, அவங்களோட address translate ஆக போறதில்ல, leading to the case remote side internet people cannot attempt to reach out my server, right? Up a server type devices, generally this translation will not work out. And a common drawback dynamic NAT pat line, remote side cannot initiate any connections, right? நம்மளோட local LAN IPs dynamic type translate பண்ணிட்டீங்கன்னா remote side இருக்கிற ஒரு user can never start any conversation, right? User type devices இந்த NAT பண்றதுல எந்த பிரச்சனை இல்லை, ஏன்னா users தான் இன்டர்நெட்ல ஏதோ ஒரு ரிசோர்ஸை கனெக்ட் பண்ண ட்ரை பண்ணுவாங்க. ஸோ அப்போ ஃபர்ஸ்ட் பேக்கெட் இவங்க லேண்ட்ல இருந்து இனிஷியேட் ஆகும். They will get translated to one of the available public AP. They can go to internet and return traffic and come back. So user type devices it works good. Server type devices this may not be applicable more often, right? In a server client conversation, the server is never going to initiate. We expect client from the remote site initiate, right? So before even we get into the types of NAT, so dynamic type இருக்கக்கூடிய ஒரு general drawback is what we have highlighted, right? Now coming to the actual types of NAT, the oldest type of NAT, the very first time NAT அப்படிங்கிற கான்செப்ட் டிசைன் பண்ணும்போது அவங்க கொண்டு வந்த module is dynamic NAT. Literally in real time nobody uses this NAT in production environment. We'll see the reason. So dynamic NAT அப்படிங்கிறப்ப it is many to a pool of IP, right? நம்ம IP provider, address provider கிட்ட இருந்து we would have purchased from the ISP, we would have purchased a bulk of public IPs, right? We ask the router to say anybody from our local network sends a packet, change their IP to one of that available IP and send it, right? So that is why we call many to pool of IP. For example, in order gateway, I'm informing anybody from the subnet, change their IP to one of the public IP lists. So let's assume I've got 4 public IPs. We are informing the router, anybody from the subnet comes in, change their address to one of this IP and send it. That is where problem starts. I've got only 4 public IP. What will happen? First user, when he sends a packet, our IP would be changed to first IP in the pool. He can go to internet and come back. Second user, when he sends a packet, he will get translated to the second available IP, goes out and comes back. And the very first 4 users alone will be able to get translated, and then they can go to internet and come back. Why do I say that? And a 5th user, when he sends an IP packet, our IP address translate பண்றதுக்கு we will not have any IP left out. And our 4 IPs have been already used up for translation. 5th user onwards, அவங்களோட IP translate பண்றதுக்கு I don't have public IP left out. So what will happen then? Packet would be discarded at the gateway, right? Upper first 4 users, in our example, first 4 users would be able to reach the internet and come back. 5th user onwards, our packets would get discarded at our gateway router, right? So if I have 100 users, I need to have 100 IP in my pool to make everybody to get translated to connect to internet and come back. So reality that won't work out. So that is why people mostly do not prefer this NAT for live environments, right? Either fine tune பண்ணி எடுத்துட்டு வந்த NAT the dynamic part, and இதுல இருந்த drawback issue, once IP pool is exhausted, further local LAN IPs cannot be translated and their packets are dropped. Right? Anyway, if I replace this NAT with the dynamic PAT, so what is PAT? Port-based address translation. The biggest advantage is what? The biggest takeaway here is it is multiple IPs could get translated to single IP on different port numbers, right? So the biggest advantage is we just need only one public IP. அதுக்காக நம்ம டைனமிக் பேட்னா எப்பயுமே many to one கிடையாது. You can also have 3-4 public APs. You can still do PAT, but one public IP would have been more than sufficient அப்படின்னு சொல்லுவோம், right? Entire network, when they reach out to internet, I can ask my gateway router to change their IP to same public IP, right? On a random port basis. Okay. அப்ப என்னோட LAN ஒரு 200 users இருக்காங்க. Everybody if they go with same public IP to reach internet, reply packets internetல இருந்து எல்லா reply packet ஒரே public IP வரும். அப்ப how does my router knows எந்த reply packet LANல எந்த client இருக்கு? That's why we translate translation here is done based on per connection. Per connection wise we do a translation. For connection அப்படிங்கறத நம்ம எப்படி ஐடென்டிஃபை பண்றோம்? வர பாக்கெட்ல இருக்கிற ஐபி அண்ட் போர்ட் நம்பர், ரைட்? அப்ப இங்க டைனமிக் பேட்ல ஒரு யூசருக்கு ஒரு டிரான்ஸ்லேஷன்ல கிடையாது. ரிமெம்பர், ஒவ்வொரு கனெக்ஷனுக்கு ஒரு டிரான்ஸ்லேஷன். இப்ப இந்த யூசரே ஒரு 10 இன்டர்நெட் கனெக்ஷன்ஸ் வச்சிருக்கானா அவனுக்கு 10 டிஃப்ரெண்ட் டிரான்ஸ்லேஷன்ஸ் நடக்கும், ரைட்? அப்ப லேண்ட்ல இருந்து எத்தனை யூசர்ஸ் ஒரே ஐபி வச்சு போயிட்டு வர முடியுங்கிறது இங்க கிடையாது. எத்தனை கனெக்ஷன்ஸ் ஒரே பப்ளிக் ஐபிக்கு டிரான்ஸ்லேட் ஆயிட்டு இட் கேன் கோ அண்ட் கம் பேக். அதுதான் இங்க கொஸ்டின், ரைட்? Let's see with some example, like if I go with the dynamic PAT, let's assume 10.1.1. He is opening up a browser and he is typing https gmail.com. Appa first enoda computer ku Gmail oda IP there, right? After knowing Gmail IP, then it will start SSL transaction. Parallelly, another user in the meantime is trying to telnet to something in internet, right? He is trying to telnet to something. அப்ப இந்த யூசர் மட்டுமே DNS ஒரு கனெக்ஷன், Gmail ஒரு கனெக்ஷன். This guy is creating a telnet connection. Let's say there are 3 different connections happening. So first, user A trying to send an IP packet maybe to a public DNS server, let's say. DNS client query is always on UDP. So for random port number learn is starting a DNS query data. So this is the first packet user A is generating, let's say. Parallelly, user B is attempting to do a transaction with some telnet server from a random port number, let's say. On port 23, it starts with a synchronous packet, let's say. Because it's a TCP, it starts with a 3-way handshake. So both those IP packets are reaching to my gateway, right? So the rule book says anybody from 10 network should be translated to the same IP on different port bases, right? In the first case of this IP address which is in 10 network, it has to be changed to 1.1.3 on a random port number, and then the packet is sent out. Second case, again packet comes from same 10 network. Anybody from 10 network would get translated to same public IP but on a different random port number. Sure. So after the translation is done, that is live or packet varumbodhu I decide to translate. After the translation is done, the entry is created in the Xlet. Then the packet is sent out. Now when you look at it, both the IP packets goes with the same public IP when they go to internet. That is why we say many to single IP. So first case, it will go to DNS server. So DNS server will reply back. On the reply packet, source will be DNS server, right? Destination would be what? My computer A. Computer A in the public IP send IP, it will reply back. From 53 back to 1024. Data it will send DNS response, right? This will be the reply packet coming back all the way from DNS. Second case, when this packet goes to telnet server, when he replies back, source would be what? Telnet server. Destination, it will come back to 1.1.3. From port 23 back to 1025. Acknowledgement comes in. Now, a SYN packet, it will send an acknowledgement plus server or a SYN packet, right? So both the reply packets, when it comes from the internet, it is coming to same public IP. So how does the router knows which reply packet have to go to which client? And a vara packet IP with port number helps me to put it back to the original IP and port number, right? Adhanale port numbers and PAT we call it as PAT identifier. Port numbers are called as PAT identifier, translation identifier, right? So for first case, anything coming to 1.3 on 1024, in the XLate entry, this entry gets matched. So it will put it back to this original IP and original port number, right? And then the packet will be sent to the appropriate client A, right? Second case, anything coming to 1.3 on 1025, this entry doesn't match, whereas this entry is getting matched. So it will put it back to the original IP and original port number, and the packet will be sent back to the respective client, right? So for public IP reply I'll be able to put it back to the actual IP and send it to internal, right? So multiple users, IP, they're able to reach the internet and come back. Now computer A, now understood what is, right? After knowing Gmail IP, what do I do? My computer A would start the next transaction. What will be that transaction? Computer A will contact Gmail server, right? Or random port number, it will send it to 443 or whatever it is. If it's HTTP or HTTP is based on it. So again, this IP packet, when it reaches 10.1.1, there is already a matching entry, right? But that was for packet coming from which port number? 5000. Right? But currently I could see adhe IP where port number PAT or concept translation is per connection. So in the connection it will do another translation. Again, this would be changed to 1.1.3 on a different random port number. Then an entry is created here, right? And then the packet goes. For a user, there are multiple translations. Per client or per user wise translation per connection wise. Okay, connections public IP successfully can be translated at one shot with single public IP concurrent, that is parallelly 64,000 connections can be translated, right? Right. So with one public IP, 64,000 connections could be translated at one shot. Right. So if in a LAN average, there are 200 users, let's say, over user or 10 connections, active internet connection, which still you would have only 2K connections. Even if I have 2,000 users in my office, 3-4 subnets, everybody is having 10 internet connections at any time. Even then, 20,000 connections only would have happened. Even if everybody is having 20 connections, even then 40K connections only would have happened. So that's why we say one public IP would have been more than sufficient. But let's say I've got enough public IP, I can use one more IP for PAT. With the two public IP concurrent, 128,000 connections, 128,000 connections could be translated, right? That's the advantage, right? So by entire LAN users with one public IP, they can go to internet and come back, right?
Sir, hello.
Yeah.
Sir, இப்போ ஒரு யூசரே வந்து மல்டிபிள் HTTPS கனெக்ஷன் எடுத்திருக்காங்க அப்படின்னா, சோ அது வந்து
sorry for interrupting. ஒரு நிமிஷம், like I think our link close ஆக போகுது. I'll send a new link.
Okay.
Please connect. Start பண்ணி, right? I'll send a link in few seconds.
Yeah.